Welcome back to Minecraft in Godot. I promised in my last video that I was going to come back and fix the performance issues I had in my Minecraft clone, but I thought, hey, it's election season, who needs solutions when we can have slogans? So yes, it is not a bug, it is a benchmark. We are going to showcase the poor performance today, we're going to capture it, we're going to measure it, and then we might actually fix it near the end of the video. I also promised I was going to take a look at the Godot 4 beta, which is out. That is probably going to be a part 3, just to be honest up front, but we will get to that eventually. But I did end up fixing the performance a little bit, and we will get into that near the end. This is MindMark in Godot. There are a number of things I did, and we will talk about what all of this is. I learned a ton on this project, and I hope that you do too. So thank you for joining me. Let's dive in. Before we begin, let's talk quickly about optimization. In my last video, I mentioned rule 0 of optimization, don't prematurely optimize, but I should also mention rule 1 of optimization, if you can't measure it, it didn't happen. I don't think I talked about this in my last one, but as I was making my world generation script, I had all of these fancy values and noise functions that I put in, and I spent a few minutes playing with the values of one of these, and then hitting play and looking at the world, and then stopping it and moving a value and starting it again. And it didn't feel like it was doing much, but I knew it had to be doing something, so I kept messing with it. Finally, I stopped and looked at my code and realized I didn't connect this at all. But because I had assumed something was going to change, my dumb human brain decided that something obviously had changed and I just wasn't paying close enough attention. So we are going to start this project not by fixing the obvious performance issues, but by setting up a way to measure the obvious performance issues so I can see if my fixes are better or worse. This is my debugging overlay, and the first thing you might notice is this big scrolling bit on the edge. This is my essentially chunk radar. So there's a few different colors that mean a few different things. The dark one is the before a chunk is generated. This means there's no chunk there. Yellow means that we are generating the chunk, and blue means we are rendering the chunk. So rendering is when we are creating the mesh or doing whatever. Yellow is when we are actually figuring out what blocks are what. So those are separated into two things, and then green is an active chunk. Two other things. If I start moving away, chunks start turning white. That means that the chunks are turned off. They're inactive, but they aren't actually destroyed. So they're just sitting there in memory waiting to be reactivated. However, if we turn off too many chunks, oh, now we have some purged chunks. So if I head back, you'll see those chunks are now red. What that means is they have been removed from memory and need to be regenerated. So if I come back in, you'll see these white chunks will simply pop back into existence when I get there. They don't need to be regenerated. See, they're popping in a bunch at a time, whereas the red chunks need to be regenerated as if they had never been generated the first time. So that's how that works. There's a bunch of other statistics here. Some other fancy things it'll do is actually export into a CSV file when you're running a test. We'll talk about that later, but that enables me to make some nice graphs to show off the performance improvements when we start improving the performance. Before I start optimizing performance, I'm going to want to fix the way that we're generating chunks. The current way we're doing this is iterating through an array. Every time you cross the boundary into a new chunk, it will look through all of the chunks in this radius, and it will add them to a first in, first out queue. And then the chunk generation threads will grab them off of that queue, and they will process them one at a time. If you notice, this is actually a different pattern. That's because when I started the game, I loaded in an increasing radius from your starting location, but we don't normally do that. We just go walking through an array. So if you have too large of a chunk loading radius compared to what your computer can keep up with, you're going to end up loading chunks that as I cross this border, you'll see it'll update and they immediately go from green to white. We are generating chunks that we no longer need, and we still haven't generated the chunk we want. So I'm going to fix this. Step one is to get rid of the queue and to generate chunks in real time. Again, we are going to have to exit this loop early when we are running out of threads. I actually had my first crash here when I forgot to include that thread limit and spun up, I think, 100 to 200 threads simultaneously. Managed not to lose the computer, but I think OBS didn't even capture this. It just froze, and it was probably 5 minutes of me fighting to save the machine because I didn't know if I had my work saved or not. So that was a bad idea. Make sure to put limits in when you're creating an unlimited amount of threads. Well, with that said, I did get that to work. The next step, though, is going to be to convert this into some other generation pattern. We don't want to be generating row by row, starting far away. We want to generate where you are. So I switched this to a spiral search algorithm, starting where you are and spiraling out. And that took a number of tries to get right. It's one of those things that isn't that complicated, and I definitely looked at an algorithm online, but I still messed it up somehow. But here we are with the final product. At this point, I decided it would be worthwhile to make a menu. The main reason I did this was because I knew I would be wanting to rerun some tests, and I wanted to have a easy way to change settings without having to go in and modify them within the game itself. Something of note here, Minecraft actually has a 96 chunk maximum radius, so mine goes up to 97 because I thought, hey, why not do them one better? Also, I can't just turn it up to 11, I can turn it up to 111. Of course, all of these numbers are completely fictional. The farthest I've generated is about 50 chunks, and it took 150 gigabytes of RAM. Yeah, that was fun. So thank you, page file. But yeah, got the menu together. I'll fancy it up a little bit later, but at least we have a basic one to start with. And with that, it's time to look at the performance improvements. So since this is a part 2 video, I am not going to go into a lot of details on how this works, but the couple things that are important, this is within that chunks script that I just updated to go to a spiral, the generate function, and what I was calling render in the code is still called update because you can call it more than once. If you are placing or breaking a block, you might need to call that. And then finalize is at the end. So we're going to go to that actual script. And the first thing you might notice is that these are all abstract. That's because I always intended to have more than one type of chunk. So here is chunk mesh, which is just one type. We'll talk about that later. But the big part is that you can see here the update and finalize calls. The generate call was a part of this originally, but I ended up moving that into its own class in chunk data. So you'll see this is just called blocks, but it is a chunk data type. And the generation is the same for all blocks. So the big thing that we're going to be testing later on is going to be the update call. It will go through and essentially figure out where blocks go and what blocks are. It will collaborate with a world gen script. So this has a bunch of open simplex noise, and it'll build all of the chunks from this raw noise data. So those work together to generate our chunk and figure out what it looks like. And then we are going to have the actual chunk will render or create the mesh or whatever we're doing. Again, there's a few different ways that I'll be doing this at the end. An important thing, this chunk data class did not exist. This was originally in this chunk mesh script, and that's the first change I'm going to make. So here we are with the performance improvements, and I have before and then I have worse, and I call that one worse because you notice it's slightly slower, but that's when I first split out that data, and so because we are now calling across to a different class, it took a little bit more time, but that's going to more than pay for itself over here, the memory per chunk. So after I split this out, I decided to drastically reduce the amount of memory we were using and also speed it up a little bit. The way I did that was by converting it to use pool byte arrays. So we were initially going X, Y, Z through this massive array and looking up things. And now we are going X, Z, and then Y, and Y is a single column of data. And we're going to generate two types of data. We are going to generate the types, which is what is this block, air, dirt, etc. And then we're going to create some flags. And these flags are going to tell you, is there something to the right, to the left, to the top, to the bottom? And so when we are generating faces later, we can just check the flag instead of having to check the block next to us. And I had a theory that this may have been slowing us down because we had this 8 megabyte array or 6.5 megabyte array that we were having to access basically randomly. And I don't think that that can fit into the CPU cache. So I'm pretty sure we're having to go to the RAM all the time, which, if you don't know modern CPU architectures, they have multiple levels of cache. But if your data isn't sitting in the cache, you have to go all the way to the RAM and it's slower. So I didn't necessarily prove that that's what was happening, but I did change it and it did speed it up. So I'm kind of have a hunch that that may have been the problem. Oh boy. Now we're going to go off the deep end and talk about Godot's pool of cows and the problems they create. Every language at its most fundamental will either pass by value or pass by reference. So low-level languages like C will pass by value. And what that means is if I have a variable here, C, and I give it a value of 0, this is like sending a box to somebody's house. You're sending a fairly large amount of data, but it is owned and held by this variable here. So if I go and I assign that over, it is actually going to send a box that matches the one it has to this other one. And if then I modify the value in D, C doesn't change because each one has its own. These are being passed around. But if you actually are watching what's happening, you're going to see these large amounts of data every time you are assigning something. This is being created and given to this little variable here. So passing by value is the most basic way that computers work. It's the default behavior, but it gets quite large quite quickly. What we really want and what Godot does is we would want to pass by reference. So in a pass by reference scenario, again, same variables, same assignment, but instead of passing this large box, imagine that you actually have a address. This would be something like a parcel locker. And so we're going to give an address to this variable. And this address in memory tells you what data is there. However, if you now are going to assign that to another one, that is going to pass along that address. And this same address will be preserved. So now it makes sense why this changes, because imagine that you receive a packet in the mail that says your parcel is in locker 15, and your neighbor receives a packet in the mail that says your parcel is in locker 15. Whoever gets there first, whatever they do with that parcel, it's going to be visible to the other one. They could take it, they could leave it, they could change it, but whatever they do, it affects you. So that's fundamentally how this works. And that leads to a very interesting type in Godot, pool arrays. As I mentioned, pool byte arrays are something I decided to use. Essentially, they are non-fragmented memory. Essentially, all the data is guaranteed to be in a single box, which isn't true if you are using, imagine these parcel lockers. You can, every time you create an array, you're creating a box full of cards that tells you the addresses of other lockers you need to go check. And so that can take time if you're running back and forth trying to check all of them. For a pool array, everything is in one locker together. With that said, turns out this is a blatant lie. Okay, actually, it's a simplification. It says that this type is passed by value and not by reference. That is not true. It appears to be passed by value. So we have, again, a pool byte array that we're passing. And let's go ahead and put some data in there. And we're going to say, I don't know, 10. So now this address contains an array with the number 10. Cool. So we're going to do d equals c. And here's where it gets weird. So what the documentation would lead you to believe is that this is going to pass by value, which means it will give it a secondary address. It'll say, okay, here you go. Here's your data. It is in your own parcel, or it is in your own locker. That's not actually how this works. It says that that's how it works according to the documentation, because most of us don't need to understand this, but it actually gives you the same address. And now you go, wait, so what happens when you modify it? These are pointing to the same location. And that's where the concept of copy on write comes in. So we have this pool array, and technically this wouldn't even be the same address either. This would be address, let's say 0. So we have this array, and there's a good chance that you are not going to want to change the contents of the array. You just want to look at it. For example, when you're calling vector20, you might just be calling that because you want to compare against it. You don't want to actually change it. So instead of creating a new box to put the data in, it just hands you the address of the existing box. It says, okay, you can look at your data in address 15. But here's the interesting part with how Godot works under the hood. Let's say I now want to change this value. So that doesn't actually make sense anymore. Let's do append, and we're going to append the value 9. So now we have the same one, but we are going to try to change it. Now, Godot promises, according to the documentation, that these are passed by value, not by reference, which means if this one changes, that would confuse everyone. So we need to do this. Well, the clever way Godot works under the hood is that it's actually going to as you write, not as you read, but when you write, it will do what's called a copy on write, where it'll take the contents of this address, it'll move it to a different one, and then it will do the modification. Now D is pointing to a unique parcel locker memory space. Beforehand, it was not. And this is called copy on write, or cow for short. And so that leads to the problems I had, where it turns out all cow operations exist within a pooled space that has a limited size. I can't figure out exactly what it is. It seems like it might be a gigabyte. Doesn't matter how much RAM you have, all the cows go in one pool, and it's a rather small pool. And if you exceed the size of it, say because you don't want to get rid of these data values, as I wasn't, you are going to quickly run out of space. So that led to my solution, which this is really unfortunate I had to do this because it actually makes everything bigger than it was, is to unpool the data when I'm done. So this depool function shouldn't have to exist. This is a limitation of Godot. And interestingly enough, it looks like this might be fixed in Godot 4. So as the goal when I am doing performance testing in 3 versus 4 is to not change the code between the two. However, if there is a hack I have to put in to compensate for the engine shortcoming, I will remove that hack. But essentially, I am needing to convert this back to an array which is not pooled so I can leave space to use this pool for other chunks in the future. So that was a weird and unfortunate workaround, and unfortunately the cows will return. But at this point early in this, I started to run into this issue, and it turns out when you're working with really big things like an infinitely generated voxel world, you're going to notice these kind of problems with the engine that you don't notice when you're just making Pong. One other change you might notice, I am getting rid of the flags array here. I'm depooling the types array because that took a long time to generate, but the flags we actually will need to regenerate again. So that was this final change. I accidentally reverted it and put it back later, but as I was going through multiple versions over the course of like 3 or 4 days, I played with a bunch of stuff, and to be fair, some things made it better, but others made it worse, and nothing was better than this first one here. I spent a ton of time just looking at various things that people online said to do. Like, for example, oh, if you switch from for loops to while loops, that'll be quicker because Godot's for loops are slower for yada yada reason. Or, oh, if you are going through and, looping every time you hit a range call, it will take time to do that call. So if you cache that, it'll be quicker. So for example here, see, I'm caching this range 1 to height into an array, and all those changes didn't really add up to much of anything. So I ended up basically reverting back to version 1 after a while. I was very hyper-focused on the profiler during this time. I had been running it in single-threaded mode, which means both the render and generate calls are happening on the main thread. Everything slows down, but I can use the profiler. You can't really profile multi-threaded in Godot 3 at least. So I finally took a step back from that and realized that my frame rate had nothing to do with the generation. It had everything to do with my debugging overlay repainting all 1000 or whatever chunks in a single loop. So I switched that to scan one line at a time. That's where that little radar sweep came from. And when I did that, the frame rate, it jumped way up. So I still don't know why the generate got bigger and the render got smaller, but I trust these three much more than I trust these ones as far as the generate and render time, because we are checking that timer on the main thread. We're not checking that timer within the threads themselves. So I fixed that, and then I realized that the generate was a lot bigger than I thought it was. So then I went through and basically just cached a few things, and that was like almost a 50% improvement. And so all the dinking around with other things amounted to basically nothing. And what I finally did was just go through and cache some things. So if you see here in my generate types, I was going through and I was calling this get biome percent, which is a fairly expensive call. And I was doing that 2 or 3 times per block. And then I just realized I only need this once per column. And so I generated that and I got the height and I did that once per column. And then I just walked from bottom to top on the column. So super simple. And that saved me a ton of time. Yeah, so I don't know. I think I've learned that optimization, getting hyper focused on the profiler and trying to shave off that extra 5% probably isn't worthwhile. Just step back and take a larger look, and you might be able to find a 50% improvement at the end. So yeah, that's about it for optimization. This, like I said, was probably a week of doing this, but it's kind of boring to go through all the little details. Most of it didn't matter anyways. With that said, we are going to move on to the last bit where I want to make more than one of these. I have chunk mesh, but I want to have some other ways of creating the chunk and to compare those. Here we are in the end game now. I am finally going to be making a few other chunk backends. This was mostly just me wanting to learn how some of these advanced topics work, but to be honest, I did expect them to work. I thought this part would be fairly straightforward I'd make it, some would work really quickly, some would work a little bit more slowly, but they all would work, and then we could move on and evaluate Godot 3 versus Godot 4. That's not actually what happened, so we're going to walk through that then. This is my chunk base class, and as you can see, there are a number of functions that need to be implemented in my individual chunk types. The generate function, this is what I talked about earlier with my chunk data type. So this will generate everything. It'll get those faces and those types in those arrays, and then I need to take that and in my update function use that to this should probably be called render, but this will be the part where I render that out and turn it into something that the engine can see. The first one doesn't actually render anything. This is simply for me to measure the performance. So if I go in and I hit run manual test, all of this debugging information is hidden by default. If you hit play on the game, you can toggle it on and off, but a quicker way to essentially play the game with this visible is to run the debug test. This is also exporting all this data out to a CSV, which I'm not looking at currently, but that is an option. So as you can see, our chunk generation times up here, this is the making them, and the render times are surprisingly non-zero. You would expect that these would be zero because all we are doing is, well, nothing. We're not rendering, right? It turns out we still need to depool the blocks. So that is a kind of common task that will take a little bit of time even when we're not rendering everything. But this is going to be our baseline. This is the quickest it's going to be. So we'll see if we can get better than 0.01 maybe? 0.0, yeah, this is a very, very small amount of time, but it still is non-zero. That leads us to the next option, chunk mesh, and this is the way that Minecraft works. If you watch a tutorial, if you decide to make Minecraft for yourself, this is probably what you will be doing. Now, if you're curious how this works, there are a number of vertices you have, 8 of them, to make a cube. So each side of this is called a face, and each face is going to be made up of 2 triangles. So they're going to be connected BAC and BCD on each face. So 764 and 745. If you're wondering why we're going this direction in particular, this actually follows the right hand rule. So if you're not familiar with that, make a fist, stick your thumb out with your right hand. The way your fingers curl is the direction, and then the face is only visible the direction your thumb is pointing, so towards you from here. So for BAC, it the face is visible towards you. If you look on the inside of the cube or the back side of the cube, you will not see these faces. So that's something to take note of when you are creating meshes. So we pass that in down here to a create face function. Here's the same stuff, and we are getting those positions. So the vertices here, this is just an array that contains that data, and you will add that to the physical location of the cube, and you will create a mesh here. Another thing is the UV coordinates. These come from the texture. The four corners are going to be four corners here. So if you are making, for example, the top of a grass texture, your BAC are going to be here, B, A, and C. Instead of being measured in pixels or something, this is just measured from 0 to 1. And so you need to divide by the size of the texture if you want to get just the size of one square within the texture. So I do a little bit of bit math there, but set that up and then put this all into this surface tool, which is a built-in Godot tool. So that is creating meshes. And this is the most complicated solution. This is the solution, as I said, that the internet will lead you to. And this is 10, 11 years old. This is probably actually older than Minecraft, but this is the way Minecraft works, the real one. My question I had is, can we do better? Godot is a modern engine. Graphics cards have come a long way. Do we need to do this? One important thing to note as we were asking this question, here's our world. It looks solid, but it's not. This is the only world that is going to do this. All other tools are going to look differently. If I can turn on clipping to go through the world, and look at that. There are no back faces. So this is incredibly highly optimized. There are the only things that we're drawing are the things that you will see when you are in the world itself. If you get outside the world, you can see straight through it. So this is what I was talking about with the right-hand rule. These faces are only visible on one side. You can make two-sided faces, but it takes more work. So this is just something to note that things are going to look different when we compare our next solution. This is the most efficient when it comes down to number of triangles. With that said, our frame rate is very high, and our chunk render time, okay, it's not bad, but it still is somewhat high. I'm wondering if we can bring this number down using other things without sacrificing the frame rate. So that is where we move on to the next solution. The next solution is the most straightforward way to do this. If you are new to Godot, you might try this and then you realize the performance is bad and try something else. But the solution is just to simply create a block. So we're going to instance a scene, we're going to place it at a location, and we're going to add it as a child of this so we keep track of it. And that is really all we're doing. I have an array so we can delete things or add things later, and that's all of it. So super simple, super straightforward, but extremely, extremely inefficient. Oh, that completely crashed. Okay, we're going to turn the settings even farther down. You're looking up at those numbers, the performance comparison. It's not actually that bad, but if you look at the frame rate, that is incredibly bad already. We're starting to dip with just a handful of chunks loaded. I am showcasing my horrible UV texturing as I was learning. I thought it would be interesting to have each chunk visually distinct so I can show them side by side and you don't get confused as to what is what. And I had so much trouble that I decided, you know what, I'm just going to keep it and use it for this simple chunk. So we can still add and remove blocks. The whole thing hitches when you do that. Goodness, that was a long hitch. We're gonna go and we're gonna fly inside the world again, and it's gonna look quite different. This is what we're gonna be seeing going forward. Notice the backside is also being rendered. These are cubes. They're being drawn as cubes. Even what you can't see is being drawn. Special note, this is a trick I use when you are digging into the world. If you dig out of a chunk, you are going to run into open air because we're not generating walls between chunks. So instead of doing something fancy, I just decided that if you are modifying a chunk, we're going to take the performance hit and we are going to, oh, it's hitching while it's regenerating this. We're going to generate these walls for any chunk that you are either building in or digging next to. And so that is just a quick and simple way to make sure you don't dig out of the world as things are being not generated. But yeah, the frame rate's terrible. This is not the way to do things. So please don't make Minecraft like this. With that said, I found a few options for performance optimization, and the first one seemed really promising. This is servers. So here's where we get into the deep end of how Godot works. I didn't know any of this. Check this out. The whole scene system is optional. Huh. So it turns out under the hood, Godot works with what are called servers. There's a visual one and there's a physics one, and audio and some other ones I'm not going to be using today. And so this is the way to go faster than I've been going before. Imagine if instead of a game engine, this is a website. What I've been trying to do is interacting with thousands and thousands of items through the web page, sending individual requests. That is the slow way to do things. The fast way to do things is to go talk to the server directly. So I have, this looks a little complicated, but I have a bunch of resources that I already created. This is just a mesh with a texture on it. Here's dirt, here's glass, here's grass, etc. So these will be loaded in, and then we're going to get their resource ID. This is how the servers work. So once we have these, the block IDs are all in an array. We'll come through, and in the update function, we will create our block, and this is only rendering. It is not adding physics, but we're going to come through, we're going to grab that resource by ID, and we're going to create an instance based on it. This is a visual instance on the visual server, so it's just a mesh, and this does not exist in the scene tree. You don't see it, and the most interesting thing is if you don't keep a reference to it, you lose it. There's no garbage collection here. This is a little bit more low level, where you can have a resource leak because if you're not destroying your things yourself. So we're going to put this in an array in case we need to access it later. But we're going to create this. We're going to set the transform. An interesting thing, I also was adding an object into the physics server, but I'll show you when I turn that back on, everything just crashes. So if you know how servers work, I would love to get some input. Yeah, note, chunk is drawn but does not have physics. That's because when I have physics, we'll run this, and there it goes. There's no actual error it spits out, it just dies. So I don't know. I could spend more time debugging that, but for now we're going to turn them off. We don't get to see it, we just get to experience it. So here we are. We're going to come back in. We're running on server mode. And first thing you notice is that these are generating in real time. Everything else, they kind of generate, but you can't see that happening, and then they will pop into existence. This one, that doesn't happen. These individual blocks are drawn as they go. Unfortunately, take a look at that render time. This is significantly worse than anything we've been doing before. I think the reason for that is resource contention. So this is thread safe. We are accessing it from 12 threads simultaneously, but I'm suspicious that the server itself may not be multi-threaded, and we might just be overloading it by trying to draw. There's probably an average of 500 blocks per chunk, and we already have 100 chunks, so we are currently up to 5,000 blocks ish. That would be about 256 blocks just for the surface plus any caves down here. So that's why I'm estimating 500. And this is, yeah, an interesting solution. It looks like it just completely stopped working. Oh, nope, it's still generating over here, just crazy slowly. Yeah, this is just getting worse and worse and worse. The frame rate is also not doing great. It's not doing as bad as you'd think, but this wasn't the magic bullet I was looking for, unfortunately. You know, it might be a magic bullet though. Multi-meshes. Check this out. For a large amount of instances in the thousands that need to be constantly processed, using servers directly is the recommended optimization. We tried that, we failed. When the amount of objects reaches the hundreds of thousands or millions, none of these approaches are efficient anymore. Still, depending on the requirements, there is one more optimization possible: multi-meshes. So this is a completely different approach to what we were doing before. Previously, we were sending either a bunch of blocks to the CPU to be drawn or individual triangles to the CPU to be drawn, but we're sending a bunch of stuff to the CPU. This time, we are sending one block and a bunch of locations where to draw that. So this is going to be utilizing modern CPU architectures to its fullest extent. An interesting thing, we're actually going to look at how this scene is set up because it is completely different than the other ones. Notice here, we still have a mesh object, but it is within a multi-mesh instance. Each of these has a single mesh, but it will place those meshes in multiple locations. So it will take this one block and it'll place it here, 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 here. So that's the way this is going to work. We actually can't append to a multi-mesh array because this is low-level performance optimized and whatever. You have to set the size and then set the values. So we're going to have a multi-mesh array that holds on to all the data we want. We're going to be appending to each kind of block. We have to have a multi-mesh for that. So we're going to come through, we're going to add to the arrays, we're going to append a transform, which is just the location where the block will be created. And then once we're done with this loop, we need to come through a second loop and we need to first resize each multi-mesh. So again, to be clear, we are resizing here in the dirt. The instance count is the number we're changing. So we're going to say we have, 256 grass blocks. We'll resize to 256 or whatever that number is. And then we will walk through each of them and we will set their transform, their location in the world. So we're going to try that. How does it compare to servers? It is quite a bit better than servers. Looks like our render time is way down. 0.3, 0.4, 0.6. I think this is actually the best one we've had so far. Even compared to generating the mesh yourself, this looks like it is quicker, and our frame rate is locked at very high. Okay, it's not locked, but it's very high. Our generation time should be the same, but our render time, yeah, that is lightning fast. So this works incredibly well. One problem, you notice these trees are kind of messed up, and I think that has more to do with the transparency than with the fact that it's a multi-mesh. You can actually see here, it depends on the angle of which things are drawn. It looks like the ones that are drawn first are rendered first, no matter which direction you're facing. So this is the direction in which the chunks are generating. The trees look great. If you turn this way, they are messed up on one side, and if you turn this way, they're messed up on all sides. So that is unfortunate. It would be great if we could fix that. I'm not sure. I'll maybe try that for the next one. Here we are with a transparent block in particular. Here are leaves. And if we go to the mesh, notice that the transparency flag is set. This has different levels of transparency. What I had been using previously was an alpha scissor. So I might try to turn the alpha scissor on and set a transparency and see if that works better. Well, that brings us to our last option. We've been using the multi-mesh. This is something we can do ourselves. Turns out Godot already has a tool for generating tons and tons of meshes, and it uses multi-meshes under the hood. And that silver bullet is GridMaps. Yeah, so these are like tile sets, but in 3D, and you simply give it a group of meshes. We're going to come over here and take a look at the blocks grid map. This is not a scene. This is a texture resource thing, but it's made from a scene. You actually have a option here to convert to mesh library. That's what that's called. So we have a scene here of all of our blocks. So here, instead of using the transparency flag, we are using what's called the alpha scissor option. This is a kind of fancy tool that will cut out any pixels from the texture if it has a alpha transparency on it. So things that are 100% opaque will show up, things that are transparent will be cut out. Everything in between is in between. And this worked well for my mesh, so we'll see if that fixes my problems with the multi-mesh. But yeah, this is my tile set here as a group of objects. Notice that they actually have colliders again. So we didn't have collision on the multi multi-mesh because I couldn't figure that out. We do have collision on the tile set. And again, you just convert to mesh library that'll export to this block tiles resource. So here we are with the tile set, and we are just going to load that block tiles mesh library that we made. And this is, wow, that is straightforward. After all of the complicated things we did, all we do need to create a grid map that is not attached to the scene, because remember, we are doing this multi-threaded, and we have to attach in a finalized call, which is on the main thread. But all we do is we iterate through. There's no creating arrays, there's no tracking data. All of that's done by the tiles, or I keep saying tile set. All that's being done by the grid map. And then we just need to set the cell. And if we want to place or break a block, we just, set the cell again. But wow, grid maps are, if this works, it is going to be very impressive to me. So let's go ahead and run this. Here we are in the world. Notice we have collision again. And this is looking, okay, there's actually holes in the world. And, the trees, we still have problems with the trees. So I think that we might still be having that problem, even using that alpha scissor. Let's see, I think it's just transparent ones. Yeah, these are fine, but if I place down leaves, it's all up to the order in which they're placed. Actually, both these look good from this side. Let's go to the other side. Dirt looks fine, leaves also look fine. Nope. There you go. You can see those clipping through each other. So transparency's messed up. I'm not going to say that that can't be fixed. It's just something I haven't fixed, and I'm not quite sure how. Let's turn on player clipping again and travel through the world. Again, you see the back sides are being drawn, and so that is more work for the graphics card. But again, graphics cards have advanced a great deal since Minecraft first came out. So using a multi-mesh under the hood to render things is pretty good, although it looks like as we're starting to pull in more chunks, we're starting to give issues. Oh dear. Okay, I take that back. This is great in theory, but it looks like generating meshes, at least right now, is still a better option. This is all sorts of weird. This is not the kind of thing that I should be generating. Yeah, the more this goes, the worse it gets. I really don't know what's going on there. Oh, back to the debugger. Oh, never mind. It's the cows. The cows are back, and the cows are destroying our tile map. Oh dear. So this is, because this is using copy on write under the hood, and that we have that small pool, I don't think there's anything I can do. We're going to put this out of its misery before it destroys itself. One note though, final thing. I do have a setting where we can render on the main thread. So we're going to go down to low. We're going to render on the main thread. We're going to give this a go and see what happens. I'm going to do this without the generation screen this time. And yeah, this is a little bit slower, but there are no holes in the world. So all the issues, I think, are still resource contention. I'm going to turn on just the frame counter. Our frame rate is low, but that's because all these blocks are being drawn on the main thread. If you notice, we don't have any of these holes that we were seeing before. The world is a lot more complete. And so I think that if you wanted to make Minecraft and you wanted to use a grid map, you probably could. I had initially optimized for meshes, and something I'm going to do in my final video is I'm going to be comparing not just the different types, but also the sizes of chunks. I think this might be a lot better if you had, say, 64 by 64 instead of 16 by 16. I don't know, that's a theory, but we'll test it. So number of things I want to test, and I'm going to be running just a whole bunch of benchmarks for the next week or so. I hope to get my final video out pretty quick. If you're watching this not immediately when it releases, just click right here to go to the next video. Otherwise, I don't know, subscribe or something. I'll see you soon. Yeah, thank you for watching, and I will see you in the finale.